An annuity is any sequence of equal payments. So for example, I finally have an adult job. So as such, I finally broke down and I bought a mattress, a really good mattress. Instead of paying the total price of the mattress off on the time of purchase, I signed up for a 90-day payment program thing. So ultimately, I'll pay it off in 3 months in 3 equal installments. So that would be an example of an annuity. We use annuities all the time for investment accounts, for IRAs, which are individual retirement accounts, where you put a certain amount, or savings account where you put a certain fraction of your paycheck off to the side into some account. Sometimes you do this, it'll do that directly and automatically, so you don't have to keep doing it. But an ordinary annuity requires payments to be made at the end of each period, normally pretty standard for credit cards and other things, other borrower accounts and investment accounts. The present value of an ordinary annuity is the value of the sum of all the annuity payments before any interest is earned. It sounds very wordy. We're not going to focus on that I guess, in-depth detail. That'll mainly help for any homework questions that might ask you for definitions. That'll help you with a few of those. Mainly, we'll be focused on the application of these things. How do these things apply to annuity-based problems and eventually amortization-based problems? So the good news is, whatever this thing annuities is referring to, which we'll get into more detail in a second here, we will not be using a formula for this section, nor the next section. Instead, we're going to use a program in the calculator called a TVM solver. TVM standing for time value money. And this calculator will do, it has a formula built into it. That formula will do everything for us. And if you use Help Me Solve This, when going through these problems, it's going to say how to do it from the formula's perspective. That will not match what I'm teaching. So I'm giving you all a heads up. The Help Me Solve This it will probably not be very helpful for this section. It might help you solve for some of these variables here, but that's about it. Instead, we are using the calculator, which is a lot more simplistic than the formula. Trust me, the formula does not look very nice. So the next question is, well, how do I use this TVM solver? And so this requires you, of course, to have a TI-83 or plus calculator. If you have anything less than this, then it's not going to be powerful enough to do the TVM solver stuff, or it just won't be programmed to happen. So let's figure out how to get to this TVM solver and then how to actually use it. So I have a pretty straightforward step-by-step process in the notes. It'll tell you exactly what to press and what to do and what you see. And I have it guided along with an example as well. So let's talk through example 1. So this is what I recommend you pull out the calculator and follow along if you have your calculator with you. So using the TVM solver, so here's an example. Suppose somebody wanted to find the value of depositing $500 each month into some annuity. So you can think about that as some accounts at 7% interest, compounded monthly after 10 years. So it does say compounded monthly. So why are we using the calculator? Why don't we use the compound interest formula? We would use the compound interest formula, except for depositing $500 every month. That's the new stuff here. This is these periodic payments. That's what separates this section from the previous section. And that's why whenever you see that phrasing, deposit this amount every month, deposit this amount every year, that is an instant indication of we're using the TVM solver. So from here, the first question is, all right, we know we're using the TVM solver. How do we get to it? So we'll start off with a fresh screen. You have a button called Apps. It should be more towards the top left corner. click on apps, and then you just press enter, enter. You're already at the DVM solver. So apps, then enter if you're following along in the notes. And you should immediately be greeted to the screen. And to discuss what all of these represent, because there's 7 different values here. These are time value money problems, or values rather. And so the capital N, so I have the descriptions written below. Capital N is the total number of payments. It's capital M is not time, but it will be based off of time. So capital N here is time, which I'll put T, times P over Y. And you might notice I do have a P, there is a P over Y variable here. So we'll get to that a little bit later. And of course, time is in years. The I, that one should be the easiest one. I is the interest rate as a percentage. So no longer do we have to convert to a decimal, because the calculator has us covered. PV and FV are present value and future value, and they are connected, because notice what the description afterwards says. Either PV or FV will be 0. Either PV or FV will be 0. They're connected. If one of them, so one of those has to be 0 in every problem. One of those has to be 0. So that's something to keep in mind. PMT is payment. So that's how much you're paying each month or each year. That's the payment. And this is always a negative value. I'll explain that a little bit later why. But for the meantime, just follow with me. PMT is always going to be a negative value. We'll see that momentarily here. And then P over Y and C over Y, these are also connected. So P over Y is the number of payments you make each year. It's the number of payments you make in a year. So if you're paying into an account every month, how many times do you pay in a year? 12. And these are always equal. Those two values are always equal to each other, as I have written back here. Always equal, always equal. In fact, even in the calculator, if you change one of them, you change that to 12, it automatically changes the other one for you. So the calculator will update that. I think going the opposite direction, it doesn't, for reasons I won't get into, but really we have 6 unique values here that we're going to be solving for. So 6 unique values. It always seems, every semester I teach this, it always seems overwhelming at first to students, because there's all these different rules now. And then by the end of the class, normally everyone's on board. Also because I'm going to make you all, help me in answering these. So with that being said, let's think about the example and how we might start applying this example to some of these values here. So we'll go back up. Suppose someone wanted to find the value of depositing $500 every month. Already what I underlined tells us 3 of the values. It tells us 3 of these 7 values here. The first value, depositing $500. So depositing $500 here tells us that PMT is equal to negative 500. PMT is always negative, so that's why I'm putting a minus. And PMT represents what payments you're making each month, each year, whatever the case may be. So in the calculator, I can go up to PMT and put in negative 500. All right, that one's in. Try to find. So I also mentioned there's 2 other values that can be determined from this. Every month also tells us two of the values. Every month tells us how often we are paying. So really this tells us P over Y, which is equal to C over Y, which is how many times we pay in a year. So how many times? It's 12. So we already have two more. 12, and it already gives us 12 there. Into an annuity at 7% interest, so hopefully that one's pretty obvious. The only thing is keep it as 7%. Don't convert it. The calculator will convert for us. The calculator converts for us. And this is compounded monthly after 10 years. So there's no place where we plug in just 10 by itself. But as we noticed for capital N would really like to know what that T value is. So there's 10 years. So capital N is 10 years times whatever we found for P over Y, which was 12. So I gave the formula down here for capital N. The time was 10 years. P over Y was 12, which we already found. And so N is 120. So that's where 120 is coming from. It's 12 times 10. And if you enter that, it'll do the computation for you.
So you're using 12 because it says monthly?
Yes.
Okay.
That's it. So that takes care of 5 of the 7 values. We're only left with 2, PV and FV. Now remember the condition it says below. One of these has to be 0. The other one will not be 0. It's going to be some number. So it doesn't seem to give us this number, and instead we're trying to find this value. So let's read the problem again. Suppose someone wanted to find the value of blah, blah, blah after 10 years. Are we concerned with a present value or a future value? Sounds like a future value. We want to know the amount after 10 years. So we want or are concerned with the future value. So that means the present value we don't care about. Or in other words, if you're depositing into some account, this is on the assumption that the account starts off at $0. There's no money in the account to start off with. And then in the future, there's going to be a lot of money in the account. And that's what we want to figure out. So now we're on the assumption that we have now typed in everything important to us. And that brings us to step 4 here. Just fill out the known values, which we did, and then place the cursor on the unknown value. So see this little cursor thing that's moving around? We're going to place it on the unknown value, which was FV. That's the future value. So now I'm placing the cursor so it's blinking right next to FV. And then step 5 tells us what to do from here. It says press alpha. Okay, so where's alpha at? So alpha is in the top left. If you click on alpha, and then you press enter at the very bottom right, then boom, this number pops up. And that number will be your answer for the future value. You have now, so if you're following along, you just now figured out the future value. You use the TBM solver. So that tells us if we deposited $500 into an account every month for 10 years with this percent interest, you're going to have $86,000 in it after 10 years. That is a significant chunk of change after 10 years. That'd probably be the amount of money I would have if I did not take all of my money out of Bitcoin right before it blew up to $40,000 a share. I am still upset about that one. I am still angry about that one. I pulled out right before it spiked.
So technically, PV and FV will be 0 until you put the cursor over it.
Yeah, and I'm going to explain that
Okay.
actually in a bit as well. But yeah, unless one of them is already given in the problem. But we'll see some examples. There's a bunch of examples we'll look at.
So one number can't be used twice. Like you can't use negative 500 twice. It's only for the PMT one.
That's right.
Okay.
So, and to help with those distinctions, again, we'll look at a few problems that kind of scattered the things we are looking for. We'll find PMT, we'll find I, we'll find N. We'll just see different context here. So let's look at example 2 and 3, which are going to be a little bit different than the other problems because examples 2 and 3 have us just looking at PV and FV for now. Let's just look at this off to the side. We'll figure out PV and FV. It wants us to distinguish which one would be 0 and which one would not be 0. So all example 2 gives us, Jane wants to save to buy a house by the time she is 30 years old. That's all the information they give us. Doesn't seem like much, but we'll have to work with it. What is the present value and what's the future value? So, how much money does Jane start off with, and how much money will she have in the future? So the first question to ask here is, which one of these values is 0? Does anyone have any intuition? Does she start off with $0 or does she end up with $0?
She ends up with 0.
Well, if she ended up with 0, she'd be frankly broke. So she's going to start off with $0. It's on the assumption that she's saving up her money. And this is why we go through these problems. This is, it takes a little bit of a different shift of perspective. So she starts off with $0, and in the future, really what my math lab will say is to be determined, because they don't give us enough numbers. To be determined. So there's really nothing to do here in terms of numbers. It's just the starting amount is 0, and then she's going to save up and get some amount of money by the time she's 30. Example 3, pretty similar, but it adds a lot more numbers here. So it's the same idea though. We're going to figure out and distinguish PV and FV.
Wait, so that's the answer for number 2?
Yeah, it's going to be a multiple choice, I believe.
Okay.
So that would be it. And they do say to be determined for that problem. So that is the answer. Example 3 is very similar. You can afford monthly deposits of $160 into an account that pays 2.3% compounded monthly. How long will it be until you have $8,700 to buy a boat? So now so there's not going to be any more to be determined. So we're going to have, actual numbers here. So does anyone happen to already see the answer? What you got?
I got the future value is 8,700 and PV is 0.
Yeah. So there's an account that you're putting money into. This account, you're assuming, has $0 in it when you start off. That's why you want to put some money into it. You're putting $160 into it. And how much money are you hoping will be in that account in the future? You want $8,700 because you want to buy a boat. So that's why we're kind of ignoring all of these other quantities and only stripping out the ones that talk about the starting amount, which is 0, and then the amount you want to have in the future, which is 8,700. If this is not straightforward so far, that's okay, because we're going to be doing this for the next 4 examples as well. So if you're not able to see that directly, we have 4 or so more problems that will apply the same idea. But initially, does anyone have any questions before we look at the real content in this section? If not, let's turn our attention to example 4. And as you can see, I have it tabulated to somewhat simulate the calculator. And we'll just go through all of these one by one. In order to accumulate enough money for a down payment, a couple deposits $362 per month into an account paying 3% compounded monthly. They make payments at the end of each period. Otherwise, that's an ordinary annuity. In other words, how much money will be in the account in 3 years? Round to the nearest dollar. If you printed out the class notes, I just added the round to the nearest dollar. So you might not see that in your notes. So if not, you can just add that. But okay, that's a lot of information. So let's read this word by word and see what we can come across. A couple deposits $362. What does that tell us?
PMT?
That's PMT. The deposit, well, the keyword of deposit. Deposits 362. That immediately tells us, well, PMT always has to be negative, so I'm just going to automatically put a minus sign. And I'll explain after this problem why. But for now, a negative and then 362. PMT is the payment. What are your monthly payments, annual payments, whatever the PMT represents? We also have per month. So 12 for what? That's PY and CY. The per month tells us how many times we are paying a year, which is what P over Y means. It's payments per year. And these two are always the same, so I'm just going to go ahead and put 12 for that one as well. So far we already have 3 of them. And we should be able to quickly get a 4th one because 3%. So yeah, that one's I. And again, we don't convert to a decimal, we just leave it as however it's given. And that's compounded monthly, but we already have the 12, so let's keep going. If payments are made at the end of each period, which that doesn't really tell us anything, how much will be in the account in 3 years? Well, 3 years is time, but we don't really have time as an explicit variable to solve for, but implicitly it helps us solve for n. So remember, n is t times p over y. So t is 3, and the p over y we found was 12. So you can either put 3 times 12, it'll do it for you, or you could just put 36. And now the question is PV versus FV. How much money will be in the account in 3 years? Are we concerned with a present amount or a future amount? That's going to be a future amount, which means that starting off, so in other words, we're looking for the future amount. We don't know the future amount. That automatically makes the present value 0. Normally this is done when you're paying into an account. You're assuming the account starts at $0, and then you're making payments into that account to accumulate to some value. So in the calculator, you can put in 3 times 12, or you can just put 36 immediately. 3, 0, negative 362. I'm going to keep having that issue. So 3630, negative 362. There we go. Now the question is, this kind of goes along with your question a little bit with what do we put here? Because if you delete all of that, delete all of this and leave it blank and try to get away from it, it makes you put something. So what I normally do, I normally just put a placeholder 0 in its place. Just something to make the calculator leave us alone. So I just put a 0. We'll come back to the 0. Yes.
How do I clear it all? Like, because I pressed the button and I'm now trying to delete it and start over.
Mine doesn't do that either. I think you just write over it. So just go down and then just type in a new one and it'll take the old one.
Yeah, as soon as you type in a new value, it'll normally, so let's see, if I typed in 45, yeah, it already started over. 36. So let's see, future value, we have a placeholder 0. These two are both 12. I don't think I mentioned, the end part should always be highlighted. See how end is just always highlighted at the bottom? Make sure yours is the same. It has to be end. If you put it on begin, it's going to mess up all of your answers. Normally it should be end by default. So, so remember what we did before. You move your cursor to the unknown value, which was FV. Press alpha and then enter. If you did all that correctly, you should have this value, which I will go ahead and put for FV. And we're rounding to the nearest dollar just because my math lab is asking for that. So 13,619. Actually, I'll put that in red because that's the one we just found. 13,619. So that is the final answer. Again, they wanted to the nearest dollar this time around, so we gave them the nearest dollar instead of the nearest cent. Does anyone have any questions about this before we continue? If not, let's go ahead and move on to example 5. A company estimates, all right, let me try that again. A company estimates that it will need $135,000 in 11 years to replace a computer. If it establishes a sinking fund, fancy way of saying some sort of annuity, by making fixed monthly payments into an account, paying 4.2% compounded monthly, how much should each payment be? Now, mindless of the fact that they're, I don't know, to replace one computer, they're going to dedicate $135,000 to that. Mindless of the weird math antics behind that alone, let's go ahead and dissect this information. So let's read this word by word and see what we can pick out from this. A company estimates that it will need $135,000. That's the first one. Where does that one go?
Future value?
That's the future value, yes. That's the future value. So notice they're already giving us the future value. That's how much they want to have in the account in 11 years. They're already giving that one. So that means what we're looking for in this problem is going to be, well, something else. So if FV is already given at that, that means we got a freebie. One of these we get for free.
Present value is 0.
Yeah, so present value is 0. Because one of those has to be 0. If you get one of them, then the other one has to be 0. All right, cool. And so we have 11 years. So remember, that one helps. So we don't have time, but this one helps us find another variable. That's capital N. So I'll go ahead and put the 11 and then times, just to remind myself that I got to put something else here. If you just put 11, you might forget about it. So I'll put 11 times to remind myself to come back to it. So to replace a computer by making fixed monthly payments. So monthly payments. That's another one.
So we're going to have 12 on pay lines again.
That's 12 and 12 and 12 there. Because remember, PY helps us determine capital N as well. So really that helps us with, that contributes towards 3 of the quantities. So again, you could put 11 times 12 or put 132. And hopefully the easy one should be 4.2%, 4.2. I'll just go ahead and fill that in there. So guess what we're looking for? PMT. How much should each payment be? So PMT is, well, I don't know. So that's what we need to find out. So let's go ahead and fill these in one by one. 2, 0. And again, for PMT, it wants me to put something there. And I normally just put a 0. 135,000 for FV, and then those are already 12s. The value we're solving for is PMT, so I'll move my cursor to PMT. I'll press alpha, enter, and it gives me, well, a negative number, which is expected. PMT should be negative, which I didn't explain in the last problem. I'll explain it here in a bit. So PMT, we have now found to be negative $806. And it does say to the nearest cent, so 36 cents. And the reason why PMT is negative comes down to the transfer of money. When you are depositing into an account, each payment that you make, you're losing that. You're putting it into the account. That's one direction of money. The future value is all the money you get back. Notice that's another direction. You're paying the money off, you're losing that money, and then at the end, or the present value, that's money on the other side. So one of those has to be negative, and arbitrarily PMT is chosen to be negative because the calculator doesn't understand these directions, and so the negative sign is the best way to convey that to the calculator, that, hey, I'm paying this money, I'm losing it, and then the final value is what I bring back. So that's the reason why. If you wanted an intuitive thought towards why that is the case. But because the negative sign is simply a product of interpreting that to the calculator, what my math lab wants is the positive answer, or the magnitude of this value. It doesn't want the negative, it just wants the positive. So that's the number it will want. If you put the negative sign, it'll say no. So it wants the positive value. The negative is simply for the sake of the calculator's interpretation.
Is PY and CY always 12?
I'm glad you asked that. Stick around for the next example. So let's keep that in the back of our minds for now. Does anyone have any questions about this one before we continue? Okay, let's move on to example 6. Okay, so a person makes annual payments of $1,000 into an ordinary annuity. At the end of 5 years, the amount is $5,863.09. What is the annual nominal compounding rate, or what annual nominal compounding rate has this annuity earned? Okay, so let's go through these one by one. Actually, instead of me identifying some of these, are there any of these blanks that anyone would care to tell me about? What you got?
CY and PY are 1.
PY and CY are both 1. Where'd you get that from?
The annual, like the annual payment.
Yes, annual payments. So I'm glad you brought that up, because annual payments means that PY and CY are both 1, because annual is just 1 payment a year. And that also helps us contribute towards N, 1 times whatever the time ends up being.
PMT 5,860.
So PMT will not be the 5,800 and all that stuff. What you got?
PMT is, the negative 1,000?
PMT will be negative 1,000. It's really, what are you paying off each period versus what's left over? Generally also the payments are usually smaller than the final amount or the initial amount. So all of these are various indications. $1,000, so that's negative 1,000.
So the top, the one is being multiplied by 5 because it's 5 years.
Yeah, so 1 times 5 because 5 years.
Is the 5,000 number the future?
That is the future. Yes, the 5,000 one is the future. So the 5,000 one, because this is at the end of 5 years, the amount in the annuity is $5,863.09.
So the present value has to be 0.
Yeah, so you're both right. I heard it from a few people. Present value has to be 0. We get a freebie there. So that means I is unknown, which also is supported by what? Annual nominal compounding rate, which that's a lot of words. Just what rate? It's just very wordy. So from here, well, we have everything figured out. So let's just see what the calculator tells us. 1 times 5 is obviously 5. I is a percent. I'm just going to put a placeholder there, 0. PV is 0. PMT is negative. Negative 1,000. 5,863.09. 1 and 1. So why is PMT red? Kind of OCD. There we go. Should be black. Cool. So it looks like we have everything situated. I is what we're looking for. So again, I'm going to move my cursor up to I, alpha solve. And it looks like I get, rounded to 2 decimal places, 7.97. So that would be our answer. That's it. We don't have to move the decimals at all because the calculator takes care of that for us. It does all of that behind the scenes. Does anyone have any questions about this? So, Roman, you have a question?
Yes, sir. Is it all right if I can talk to you after class?
Yeah, that's fine. Thanks for letting me know. Yeah, that's perfectly fine.
All right. Thank you.
Yep. All right, so for example 7, I figured maybe I'll just pass this off to you all. Just try to do it on your own. Might be a good way to see if you can do it independently. About 2 or 3 minutes, and then we'll bring it back together. This might be a bombshell to some of you. PV is not 0 in this problem. The reason why, so this is the first problem we've looked at where we're starting off with a value because instead of putting money into an account to accrue some money over time, we're trying to pay off money. So this is a credit card account. So you're starting off with, oh shoot, I can't believe I've been going on all these lavish trips and I've been just charging my credit card all this time. Now I got $2,000+ in credit card debt. So that's the amount you're starting off with, and in the future, how much debt are you hoping to have? 0, exactly. $0 in debt in the future. That's why these values are, and then I'm pretty sure the rest of them should be straightforward. Let's quickly go ahead and put these in the calculator. 0, 12.99, 2514.87. Okay, negative 200, 0, 12, 12. Alpha, solve. And our final answer is going to be 14. Round up to the nearest integer is what it states. So it says no matter what your number is, round it up to the next integer.